Okay, so in the figure here we're asked to find x. Alright, here it is. Now we should also show some calculations. So if in this triangle ACD, if we knew that this kind of looks like a right angle, but if we knew it was, then we could use Pythagoras' rule straight away and it would be nice and easy, but it's not given, so we need to show that this is true. So we need to use the information that's given in the diagram. We can see that we have a triangle over here, ABC, which is a Pythagorean triad, 3, 4, 5. So we know that that has to be a right angle. And the right angle is at B since 5 is the longest side of the triangle. So the other right angle triangle we have here is DEC. And we see if we line up the smallest sides and the middle side and the largest side, that there's a ratio here between these two. It's another Pythagorean triad just multiplied by 3. So it's actually not given as a right angle, but because it is a triangle, we know that from the hypotenuse, longest side opposite that, it will be a right angle. So now these two sides have the same ratio. We should be thinking about similar triangles. If the sides are in the same ratio, we know that they have to be similar. So if we write down a similarity statement between triangle ABC, and let's get the order correct. So that has to be similar to the matching side to A. Well, the angle A is opposite to the smallest side here. So the smallest side is 9. We have to be looking at C. So C is the matching angle to A. And we can write that in just with an alpha, let's say. And also B comes next, that's the right angle. We can see that that's E. The other one must be D. The reason, as we said, the sides have the same ratio. So now we can calculate the other angle. So this other angle must be complementary, so it's 90 minus alpha. And we know in similar triangles all the angles are equal. So this one here also is 90 minus alpha. So the last thing to do now is to consider this straight angle here. So all of these angles must add up to 180 degrees. So we've got 90, let's call this M, let's say. So 90 minus alpha plus M plus alpha has to be 180 degrees. And alpha minus alpha will be just 0. And M will be 180 minus the 90 degrees. It has to be 90 degrees. So we've shown that this here is a right angle, which is what we were hoping for at the start of the question. And now we can use. So we've shown that in similar triangles, the angles must be equal, and so that angle must be 90 degrees, ACD. So let's use x as the hypotenuse, Pythagoras' rule. The other shorter sides are 5 and 15 squared. So that's 25 and 225. So to get x now, we have to undo the squared with the square root. And that's 250 if we add those together. And we should spot that that's the square root of 25 times by the square root of 10, which will simplify to 5 root 10. And we're given the units, we should include that in our answer.